Good morning, grade 9. We're going to start section 1.4 today. I'm going to do this in two separate videos because one of them is going to be a review and the other one's going to be the actual lesson. So before we had school dismissed, we talked about different shapes, and one of the ones that we focused on quite a bit was the triangular prism. Okay, and we talked about how a triangular prism is actually made up of two different types of shapes, one being triangles and the other one being rectangles. And I asked you guys to make a name for them, so I gave you the ones that I always use, which are kind of weird, and I think they're from when I was back in grade 9. I call that one the slide. I call this one the bottom, and then for some weird reason I've always called this one the spine. You don't have to give them names. You can call them rectangle 1, rectangle 2, rectangle 3, but I just like to keep myself organized like that, and I remember things that are weird like that. Okay, so how do we find the surface area of a triangular prism? Well, the first thing we do is we realize we have triangles and we have rectangles. And then we have to go back to our formula sheet, or some of you will have a good memory, okay, to find the surface area of a triangle, or the area of a triangle, sorry, base times height divided by 2. Because, remember, a triangle is really half of a rectangle. So, how many triangles are in this triangular prism? 2. So we would take this formula and then we'd multiply it by 2. And my shortcut is I just simply cancel those, right? Divide by 2, multiply by 2 is negated because it turns into a 1. So I'm just going to concentrate on this whenever I'm doing a triangular prism. So now I have to give numbers here. So I'm going to tell you that this is 10 centimeters. The thickness of this thing is 3 centimeters. The bottom is 8 centimeters, and we'll say that the height of this thing is 10 centimeters. So do we have enough information? We certainly do. The triangle's base is 8 and its height is 10. So we're going to go 8 times 10, which is 80 centimeters squared. And I'm going to circle that so that I remember to add that. And now I'm going to start doing the rectangles. Okay, so I'm going to say that I'm going to do the slide first. The slide is a rectangle, its length times width, so the length of this thing is 10 by 3, which is 30 centimeters squared. Remember, my coping strategy is I circle them all the time so I remember. And now I'm going to do the bottom, also a rectangle. Bottom is 8 by 3 wide. 8 times 3 is 24 centimeters squared, because area is always a square unit. And now finally I'm going to do the spine, also a rectangle, length times width, and the spine is 8, and then it's 3 wide if you could turn that over, because it's the same as the width at the bottom here. Okay, so we have, oh, sorry, did I say 8? I think I meant 10 by 3, which is 30 centimeters squared. And now remember, total surface area means we're going to add all of these things together. So when we add that, we get 4, 5, 6, 7, 8, and 8 is 164. And we're not going to forget this. This is really important, centimeters squared. Okay, so that's just the review of how we find the total surface area of a triangular prism. And now we're going to move on. We're going to do one other shape that we talked about, and that is a cylinder. And we talked that cylinders are made up of circles and then this curved edge. Remember, we talked about a soup can. In grade 7 and 8, you probably did nets, we call them, and you would realize that this thing is actually a rectangle when you spread it out. If you took a soup label off of a soup can, it turns into a rectangle, okay? But specifically, we use this formula when we're talking about cylinders, and you might see it written a different way. Sometimes teachers will write this without the 2 in front. It'll just say pi r squared, which is how you find the area of a circle. But I always write a 2 out in front because there are 2 circles on a cylinder. And eventually, like when we start to take off overlap and things like that, you might have to manipulate this or eliminate it sometimes if we were just wrapping this thing like a label. But we'll get to that after. 2 pi r h, and that's the curved side of this thing. Okay, so let's go ahead and we'll try this thing, and we need to give this thing some dimensions. So I'm going to tell you that the radius here is 5, and the height of this thing, we're going to try and keep it nice and simple, is also 5. Okay, numbers that are easy to work with today, mostly because I'm going off the top of my head here. Okay, so here we go. I always rewrite my formula and I fill in my variables, 2 pi, and then the radius is 5, and the height is also 5. So now I'm going to go through and I'm going to figure this out. And many of you have a pi button on your calculator. Feel free to use that. Okay, I'm old school, so I usually type in 3.14, which works too. Maybe I'm dating myself here. Okay, remembering that 5 squared is not 10, it's 25. So we're going to go 2 times pi, 3.14 if you want to use that, times 25. And you get approximately 157 centimeters. Okay, plus, and that's squared units because we're finding area. 2 times pi times 5 times 5. 2 times pi times 5 times 5. And lo and behold, it works out to be kind of the same thing because I use the same measurements. And now remember total surface area, and that's sometimes a little easier to see when we're talking about a cylinder because you actually have the plus sign sitting right in there. And when you add those two together, you get 314 centimeters squared. Okay, so that's your first lesson of the day. Now what we need to do is we need to practice these a little bit because now we're going to start making composite objects out of them. And the example that I did on the board before you guys left was I built wedding cakes, right? And I piled things on top of each other, okay? The other thing that I want to just remind you before we get started is if I gave you a cylinder, okay, and I told you that the dimension across the whole thing was 14 centimeters. We have to remember, okay, that the dimension across the middle of a circle is called the diameter, and we're only going to use the radius, so we would need to cut that in half. So we would have to take that and divide it by 2, and therefore the radius would be 7 centimeters. Okay, so that's just another little thing that we have to remember. Okay, so stay tuned. I'm going to put a surface area assignment that's just these basic shapes on the Google Classroom, and then the next video is going to be me putting these different composite objects together, and we're going to find the surface area, and I'm going to do a couple of examples of that. Okay, coffee break.